Ladies and gentlemen, welcome to Metakosmos, the launch of the Spacesuit company. Mr. Metakosmos, as I call him, is none other than Kiriti Rambhatla. And here he is. Kiriti, in fact, is a very well-travelled and very well-versed electrical engineer. So his background is in electrical engineering. He has a bachelor's degree. He is, in fact, the founder and chief executive officer of Metakosmos. And he, as you know, is working on next-generation spacesuits. And before founding Metakosmos, he was the head of emerging technologies at LinkedIn, which I'm sure you're all familiar with. And that, as you know, was acquired by Microsoft in 2016. His work on innovation appeared in Forbes magazine. And among other things, he's been a speaker at the European Commission and at various TEDx's around the world. With more than 15 years of experience in technology across the globe, he has, as I said, a bachelor's degree in electrical engineering and an MBA with specializations from the London Business School and MIT in the United States, which, as you know, needs no introduction. As a student, Kiriti was a member of the Canadian Aeronautics and Space Institute. Ladies and gentlemen, please welcome Mr. Metakosmos, Kiriti.
We all know that these things are extremely expensive, time-consuming, and that meant it led to a vicious cycle. Very few people getting into that cycle, very few suits being produced, and so very little intake, and it kept happening for the last few decades. And when you look at travel modes, you start all the way from sea travel, and then you kind of work yourself up from road travel all the way down to supersonics, hypersonics, and spaceflight. And the danger factor increases as you go along the chain. And so it's very important for people to actually train for them really effectively before they actually engage in actual spaceflight. Now, there's something called latent demand that we've been looking at over the years. So I get asked this question all the time. There's no business for spacesuits, so why are you guys even bothering with it? I think there's a lot of demand, but it's just latent because it's out there. And you can look at some of these numbers on the web. Every time there's an application for an astronaut program, there's thousands of people applying for a handful of positions. And there's incredible research out there on the horizon about what you could actually do in microgravity. That is 3D printing human tissues, manufacturing. I've read a report that you could actually cure cancer. So think about the possibilities of medical tourism, taking people up into microgravity, curing cancer. It seems like science fiction, but you know what? You never know what the future holds for us. There could be an incredible amount of possibilities that we're not aware of today, but we could definitely take steps in that direction. Now, space tourism is great, but there's also a lot of astronaut training activities that people are planning as we speak today. Might be functional in the next 5 or 10 years, so you might see that being very similar to a commercial flight training program. Anybody here who engaged in flying planes? I flew a plane for about an hour and a half, Cessna. I was so scared that I crashed it that I stopped the plane. But it was so accessible to us, right? So I believe that is going to be the model that we're going to have for astronaut training as well. So people can engage, recreational purposes, have some fun. You don't have to fly, you might get a certificate, but it's going to teach you a lot of things. It's going to teach you endurance in extreme environments. And that's extremely important, whichever side of the global warming debate you're on. Now, so what we did after a lot of research is define the problem space. So what is the actual problem? And it's surprisingly multivariate. So obviously your body is going to face a lot of hurdles when you actually engage in anything space related. There's a high cost of production that we're all aware of, and there's a lot of latent demand. So how do you actually build a solution that could cater to all these variables? That's when we thought of Kosmosuit. So we're not calling it a suit, but a suit platform. And I'm not saying platform in the sense of softwares that we see today. It's literally a platform that you could actually plug a lot of things onto as you build your way from domains. And I'll explain that in a bit. Basically, it is a full stack platform that's meant to cater to multiple environments. And when you engage in those environments, it's going to collect intelligence on your performance. And that is very important for us to design effective suits in the future. The biggest hurdle today is for all the people that have lived on the planet or are living on the planet, perhaps 100 billion people, 600 people maybe have been into space, and that's statistically not representative to design any system. And then it's got to be accessible along with being competitive and modular so that you could actually swap components if you wanted to. Taking this in this direction because you don't build competencies and capabilities directly for space. You have to first understand how it works on land, perhaps underwater, and then you build it for air, and then you take it to space. What you see behind me, these IVA prototypes or flight suits that probably fast jet pilots could get into, are the ones that would eventually transform into IVA suits. And then you understand more about that performance and you take it down directly. An EVA suit, which is the concept that you see on the banner right there. That's the aspirational design, but we hope to get there someday. And then the heart of this entire system, I would say, is the software, because it's going to be your black box of information. And that could come in different forms. It could come through biochemical signals, it could come through electronics, it could come through sensors, it could even come through visual inputs like motion capture. So you could actually get in front of a camera and carry out a certain type of movement, and you could pick up certain signals from that activity. And all of that could be stored in the software. And this would empower the way you would actually train because you'd understand information, hopefully in a matter of hours, if not real time. And then the most important one that I refer to is the software interface. So we've spoken to a lot of people in the medical community, essentially to understand how could we non-invasively capture biomarkers? Because it's easy to get your blood tests and then get all this information, but the aim was to see if we could do these non-invasively and sort of put them in clusters. So you could get performance data, not just on your body, but your suit as well. So these are all classified into different segments, and we're going to be building them maybe in sets of 10. So the first set of 10 data points would come from the heartbeat that's easily accessible, and then we start building more metrics based on that data. And the latent demand that I was referring to spreads across so many domains. I think this is what people would want to see. If you really move the lens away from spacesuits and talk about extreme environments and performance clothing, the market is big, let's just say. So if you could actually look at all these avenues together through one lens and one platform that could be customized, because when you look at the design of the systems, you could actually go for the least common denominator approach. You design a certain set of things which are consistent across all these suits. And then you have to customize maybe 20 or 30% of the suit for the end environment. And it all brings me to the diversification of the economy, because every time I went to space conferences, incredible work around satellites and rockets, but it just felt like there wasn't enough happening in human space flight and other industries, and I kind of understand why now, but I think there's great possibilities in the next 5 or 10 years for people to actually start investing in human spaceflight services and positioning Australia after Russia and USA to have the life cycle capabilities for human spaceflight. And this could mean data services, this could mean suit services, it could mean a whole bunch of other things. And we're just here. They've helped us with PhD students early on to get us up to speed with what is biomechanics. I had no idea what biomechanics was until I started that project. Understand things related to battery management systems, like how do I know if my battery is performing to the levels that it is expected to perform, and a host of other things. And now we've also started bringing in students from different levels, like master's and undergraduate students, and internships down under, through whom we've actually brought a couple of people on board from Europe, like mechatronics, and then recently we've onboarded a couple of aerospace engineering graduates for internships. But we've, I think, cumulatively invested through all our partners and other people to 2,000 hours in our production. And this is just the starting stage. I'm assuming the testing is going to be like times 10. You need to go through a lot of rigorous testing procedures to be able to put things in space. So it's a long road, but we're really excited with the possibilities.